All right, I'm really hoping I have you good and trained by now. We've got a systems of equations here, and I hope you're thinking, all right, should I graph? Should I substitute? Or should I eliminate? Because all three methods will always work, right? It's just a matter of fitting them to the problem. So I noticed one thing really quickly. I've got slope-intercept form here, and I almost have slope-intercept form here. So if you're a fan of graphing, I might just rearrange that top one really quickly and graph them to get my answer. If you like to substitute, you might have noticed, oh, look at that. I can just substitute this in for y, and I can solve it pretty easily. Now, since this is all about the elimination method, I'm going to use the elimination method to show you. But I again hope that you've got this little process in your head trying to decide which method to use. Now, we also know the elimination method is good when everything is lined up already for us, which it is, right? So that's helpful. Now, the thing that I do notice, though, is if I were to add all of these up, nothing would eliminate. My x's wouldn't eliminate and my y's wouldn't eliminate. So that means I got to jump in and force something to eliminate. I see a couple potential things that I could do here. And by the way, there's a lot of right answers. I think what I'm going to do is I'm going to divide this entire thing by -2. I have a feeling that's not what you would have thought of. You might have thought, I'm going to multiply this whole thing by -2, which, by the way, would have also been correct. Or perhaps you wanted to eliminate these x's and you multiplied by a -2. Wow, look at that. We would have had more things eliminate. Sorry, I'm having an epiphany moment. That already tells me some things about this equation. So before I ruin the excitement here, I'm going to jump back to my original plan. You can multiply every term by something. You can also divide every term by something to make it eliminate. And watch what I just did. 2 divided by -2 gives me a negative y here. And I now know that when I add, these y's are going to reduce to 0. 10 divided by -2 gives me a -5x. And as I kind of alluded to earlier, I noticed something a little funny. I'm going to have more things eliminating, aren't I? And now, let's see, 4 divided by -2 gives me -2 over here. All right, so now what I've done is I've created a new equation here to eliminate with this one. And I'm noticing very quickly here that on the left-hand side, these reduce to 0, these reduce to 0. So I keep getting my equal sign in the wrong place. So don't do what I'm doing. Be careful. The equal sign is right here. So that means it needs to stay right here. It needs to stay right here. So I have 0 equals 0 plus 6 because -2 plus 8 is 6. So I'm ending up here with 0 equals 6, which is absolutely not true, right? 0 does not equal 6. Do you remember what that means when you get something that is not true? I hope you thought, oh, that means there is no solution to this problem, okay? These are parallel lines. So maybe I should have put them in slope-intercept form to begin. I would have noticed they have the exact same slope, but different y-intercepts, meaning they're literally never going to intersect.